Hello everyone, today I will present my research work. Title of this presentation is Improving Process Discovery Results by Filtering out Outliers from Even Logs with Hidden Markov Model. At first, we will introduce some definitions. My research work is based on process mining technique. Process mining apps to even logs to extract process knowledge in form of process model and provide valuable insights to help better understand, monitor, and improve the current processes. The starting point for the process mining is even logs. This even logs is a snapshot. An even log contains information about a working process as it takes place, such as case ID, time step, and activity name, which is well-defined step in the process. An even log may also contain other information related to the event, such as operators and the record data related to the event. We use a process model to represent knowledge mined from the even log by the process discovery algorithms, such as a Petronet. Petronets are the well-studied process models and many existing analysis techniques can be used to analyze the models. The most important learning task in the broad field of process mining is called process discovery, which is concerned with the derivation of process models from even logs. Over time, a range of process discovery algorithms have been proposed, such as alpha algorithms, heuristic miner, and the inductive miner, to name a few. Many process mining algorithms are based on the assumption that an even log faithfully represents the behavior of a process as it was performed. Unfortunately, many real-life process even logs often contain noise and infrequent behavior. Noise refers to activity sequences that are incorrect, such as incomplete event trees, duplicate activities, faulty execution of the process. However, infrequent behavior refers to a behavior that only occurs in exceptional cases within the process, which means infrequent activity sequences are correct, but regular activities that handle non-convenience cases such as exceptions. In this work, we consider both noise and infrequent behavior to be outliers. The presence of outliers will lead to infrequent paths within the derived model. This causes the precise model to become cluttered and results in a model that is simple, not an accurate representation of the accurate behavior. For instance, the heuristic miner can have a 49% drop in precision when the amount of outliers corresponds to just 2% of the total log size. In order to limit this adverse effect, even logs are subjected to a pre-processing phase where they are cleaned from outliers, especially in the context of large event logs exhibiting complex process behavior. It's a time-consuming task, and there's no guarantee on the effectiveness. Some researchers propose approaches to filter out outliers from an even log. Some existing work apply the traditional data mining approaches to filter out outliers. Among these works, they do not consider the structural information related to the activities. The Prüm framework offers several plugs for filtering anomalous data. These filtering methods are performed based on activity frequency, positions, certain attributions associated with the event. So they only consider this information the same. They do not consider the structural information. And several studies perform filtering approaches based on sequence mining algorithms. The same. They do not take incomplete traces or multiple missing events into account. So in this work, we want to use a hidden Markov model to filter out outliers from even log paired to applying process discovery algorithms. A hidden Markov model is a powerful statistical modeling tool, so we can apply it to analysis of the result and the process. The hidden Markov model have 5 elements, where the first is finite set of hidden states. O is a finite set of observations. A matrix is a hidden state transition probabilities matrix. B matrix is a observation probability matrix. and pi is initial state distribution. Here is an example. Simple hidden Markov model example. So this hidden Markov model has two hidden states, S1 and S2, and a set of observations, A matrix, B matrix, and the initial state distributions. In this example, the probability of a transition from hidden state S1 to S2 is 0.8. The probability of producing the activity A in hidden state S1 is 0.5. So the goal of this work is applying hidden Markov models to filter out outliers from even logs to improve process discovery results. We have three challenges in our work. First, how many hidden states existed in a given even log. The second, which part of given even log is used to construct the hidden Markov model. The third, how to infer the probability parameters from a given even log. Based on these three questions, we design the following steps. First step, we construct the mainstream process model to obtain the hidden states. Next, we apply the original even log using the mainstream process model and obtain a mainstream sublog. The mainstream sublog shows us where the even traces fit within the mainstream process model. For the third step, we propose a set of rules to infer parameters based on the mainstream process model and the mainstream sublog. In the next, we will introduce the step in the detail. So the first step is obtain the mainstream process model. Mainstream process model represents the primary process behaviors across the total even logs. We have three strategies to select the mainstream behavior. First is the event trace selection strategy. In this strategy, we select the top frequent event traces from the grouped event log. The second is activity selection strategy. In this strategy, we calculate the frequency of each activity in the event log and then select event traces that cover the frequent activity sites. The last one is combination selection strategy. In this strategy, we take the top frequency event traces and activity into consideration. So next, for the event trace in the remaining event logs, we identify whether an event trace is replayable on the mainstream process model. Here is the replayable definitions. For example, here is a mainstream process model derived of this mainstream behavior. From the remaining event log, we found the event trace species activity sequence is A, B, E, B, D is replayable. So we treat the replayable event traces and event trace corresponding to the mainstream behavior as a mainstream sublog. And then view a hidden Markov model is a probability model. A patronet is an analysis represent and does not directly support a probability description. Because of this, we propose a set of rules to infer the probability parameters of a hidden Markov model from the mainstream sublog and the process model. So the first, the hidden states. Each place in the mainstream process model is represented by exactly one state in the hidden Markov model. The observations are the grouped event logs that corresponding to the mainstream sublog. And this is the description to the construct hidden state transition matrix. We use the labeling function sub to get the frequency of event traces, which refers to the superscripts of the activity sequence in the grouped event log. And here is the description of the observation probability matrix, which is a B matrix. And for the initial state distribution pi, the input place of process model is P1, so we set the hidden state corresponding to the input place is 1. So here is an example of the previous, here is a pi of the previous example. The second, so when we get the hidden Markov model, we calculate the probability of the occurrence of each event traces based on this hidden Markov model. We use the forward-backward procedure, and then we compare the probability with the user-defined threshold. We treat the event traces which the probability is lower than the threshold as the outliers. So the objectives of our evaluation consist of two components. The first, we evaluate if filtering out outliers by using the hidden Markov model can be improve the quality of the process model that's discovered from the event log. To do so, we choose an existing inductive mining algorithms and apply it on the same real-life event logs with and without the approach. The second, we compare with the performance of the proposed approach with two commonly used filtering approaches, using the artificial and the real-life event logs. The artificial event logs are generated from the processes and the logs generators, which is an open source tool that's used to generate artificial event logs based on the user-defined process model. And here is the performance metrics. So this set of experiments is to evaluate whether filtering out outliers by using the hidden Markov model can improve the quality of process model. From the result, it's clear that then we use our proposed approach to filter out the outliers from an event log can achieve the higher fitness precision and the F1 score with different real-life event logs. And here is the result of experiment 2, and from this result we can easily know the proposed approach outperforms the two commonly used approaches on average cases. And here is the result of experiments in real-life event logs. So in this paper we present an approach that's using hidden Markov model to filter out outliers from event log, and the experience indicates that the proposed approach improves the quality of process model, and the result of experiments shows that this filter out outlier method outperforms two commonly used filtering approaches.